Swayam Prabha. Digital India. Educated India.
Hello and welcome to this lecture on manufacturing process technology, module 1. This is part 1, module 1, and I am Shantanu Bhattacharya. I am an associate professor at the Department of Mechanical Engineering at IIT Kanpur, and I will actually be teaching you or taking you through the whole sequence of steps which are needed to understand the manufacturing processes in great details. So let's have a sort of a brief introductory overview of what I am going to talk today. I am going to actually tell you about some of the manufacturing system approaches. Then I would also discuss some basic manufacturing processes like casting, forming, fabrication, material removal. I would also like to describe some of the advanced machining processes, ECM, EDM, EBM, LBM, AJM, USM process, etc., and then micro manufacturing processes, etching, deposition, lithography, replication and molding, dip pen lithography, compression molding, nano imprint lithography, so on and so forth. So this is only an introductory lecture. It may go over several modules, and the idea is that you should be able to know at a glance about the processes before getting into the aspects related to the modeling of the process technology. This course would be actually intending to give an insight into the people who are process designers, and it would really be a parametric analysis of all these different processes, but we have to organize the way that the processes are laid out in sequence, and that is why this introduction lecture is very, very important. So when we talk about manufacturing through a systems approach, what is important is that manufacturing facility is really a value adder. Okay, so as you can see here right in this figure, there is a facility which is adding value to an input material which is actually more in the form of a raw material which may not have otherwise any value, but once the value is added by the manufacturing facility, the output which actually comes out of such a facility generates wealth, because the output has some value coded in it. And so therefore it is very important to plan the facility in a manner so that this value can be added according to the aspirations and needs of various sections of the society, and if you can add the value in the right manner, then the product can be positioned in the right manner. It will definitely generate a lot of wealth, which is actually the reason why a manufacturing facility exists. So definitionally, manufacturing technology really provides the tools that enables production of all manufactured goods. These master tools of industry magnify the effort of individual workers and give an industrial nation the power to turn raw materials into affordable quality goods essential in today's society. So if I look at such a system which has this manufacturing facility, it really comprises at the heart a set of manufacturing processes, and really it is the process which is the key to the wealth generation. So on one side there are various inputs like sales fluctuation, raw materials, cost and availability, business environment, social pressure, resources and plans, and on the other hand your production rate and quality. You have the deliverables which are actually the products coming out of the manufacturing system. You also have profits and reputation to keep in business, which is also very important for such a system, but really this system would be balanced and it will work well if the key to it, or the heart of it, which is manufacturing process, is well balanced and well designed. So therefore in this current day it is no longer essential to overemphasize how important manufacturing is for our country and our society, and the processes therefore automatically become the bread and butter for such manufacturing systems. Let us talk about some of the very commonly available processes. For example, if you really look at the paradigm of all processes, the manufacturing processes can be split up into primary processes and secondary processes. The primary processes are really those where the overall shape or size of an object can be given. Let us say for example we talk about casting process, which is a primary process, or a forging process where there is a different shape of the iron, but you are actually heating it up and trying to shape it so that there is some overall shape which is incorporated, or overall size within which the material is constrained. And so this overall shaping of the material is known as a primary manufacturing process. The secondary manufacturing process comes into play when you talk about such primary products coming out of primary processes in assembly, so that they can develop something like a power in power out kind of a system, or alternately you may have some kind of a joining exercise between two, so that a complex shape can be created. But overall those processes are categorized into the secondary manufacturing processes. So let us call the primary manufacturing process like casting process. These are the only processes where liquid metal is used. So casting is one of the oldest known manufacturing process, and if I look at how the casting process is accomplished, it is done by something called the preparation of a mold. This mold is normally made out of sand, but then there are many other variants of the mold which can be used time and again when the processes differ in terms of its output, etc. But the mold is basically something which is the negative of the shape that you want to produce using the casting, and the mold is needed because it is essentially a containment for the melt of the material, which would then solidify and come out as a solid object of exactly the negative shape of the mold. So if you have to make a spherical ball, you need a cavity which is the negative of a ball as the mold. So the mold is prepared typically by using some kind of flasks, which are also known as cope and drag, and some material which is a refractory material. So refractory material really is a material which retains its strength at high temperatures. Sand is a very good refractory material, for example. So what you do is that you have a flask set which is shown right here, which we also and also you can see this is the assembled view of the whole mold with the different flask sets, and you have different layers of this each containing one flask, and the flask therein containing refractory material. So you start with such a flask. This is one flask, for example, where you are actually pouring the refractive material sand and setting up the mold. So for doing that you really need something called a pattern. A pattern is really the shape or size that you want to cast. So you are putting a pattern inside the sand, and then you are trying to hammer the sand or compress the sand in a manner so that it forms a mold around the pattern, and such a pattern can be in several pieces. So therefore different levels or different flasks would contain different pieces of the pattern, and thereby you have now when we take out the pattern, for example, the pattern would actually create a cavity in the sand, and this is the cavity which you really need to fill with the molten material. So once you do that, then obviously you have something called a mold. Now the mold has, in addition to the pattern, several other regions which is very important for the metal transfer process. So there is a liquid metal that you are pouring, so you have to run the metal through a substantial section of the mold before it enters the pattern, so that the momentum, etc., is reduced and the pattern does not get the mold does not get damaged. So there is a riser, there is a runner, there is a riser, and risering section is normally because you need to have an indication from outside that the metal is also oozing out after filling the whole cavity. So from one side the liquid metal is coming, filling the cavity, the mold cavity, and from other side the liquid metal is coming out. So there is a combination of this riser, runner, and the mold, and then obviously into the runner you need a gating device where you have a pouring basin, etc., where the metal is poured. So therefore this is a process really where you are trying to guide the liquid metal within this system of the mold, so that the material goes and comes into a cavity which is of the shape of the negative shape of the material, or the part that is to be produced, or the size that is to be produced, and that would really create the mold. So once the mold is ready, on the other hand, if you have liquid metal, so obviously you will have to heat the pieces of metals together in a furnace and take it to the melting point, so that the material gets flowable or fluidic or liquid in nature, and then this material can be further superheated also if you wanted the solidification process to be more controlled, etc. So therefore, the liquid metal is poured into the mold, and after the pouring of this liquid metal into the mold is taken off, so that after the solidification of the material happens, and so the material is extracted, the solidified material is extracted from the mold, and the mold is reused. So you can reclaim the sand by shaking out the mold, and you can use this sand after some more preparation for a modified or for another application into another mold flask and so on. And what comes out is basically a component where you have to clean the component. So you have to sort of trim off the component. Let us see this figure for example. So in this figure you are pouring the molten material through a ladle into this section which is the runner, and it goes all the way into this particular part, where the part is again filled with some kind of a core. The core is normally used if you want to create a hollow casting. So and the material moves around this core and comes back into the riser size, and that is how when you get the solidified metal, it will be having the basic part, which is probably the part in this particular region, plus the runner side, because this is also going to get solidified, and the riser side. So you have to remove the risers and the runners from the part so that you can extract the basic part. You can also do a shot blasting, so that whatever small sand impurities are left on the surface of the material actually goes away, and then finally you do the inspection, and you can add a secondary manufacturing process like machining here, or maybe even treating it further through certain thermal cycles, so that it gets heat treated and the strength gets modified in according to the requirement. So that is how you can finish a casting part. So typically a casting process is necessitating the preparation of a cavity, okay, in a refractory material, and also a step where there is a molten metal being poured into that cavity, further followed by the material in the cavity getting solidified because of heat transfer across the mold, and then the object after solidification is finally removed and processed, so that you can have a shape, overall shape given to the object. That is why it is a primary manufacturing process. So this is just an overview of how a casting is done, but there are many intricacies and many modalities in terms of process modeling, where you can actually figure out what is going to be the length of the runner versus the riser, what is going to be the time it takes for the liquid metal to reach, and during that time what is the impact of solidification on the material, or for example when the material gets to fill the cavity, after that what is the impact of the solidification into the overall grain structure. All these aspects need to be revealed in great details when we do the section of the casting area, or process modeling for the casting. The other process that we would be studying in great details is pertaining to the secondary manufacturing process, at least in this particular part or module. That is how I have structured the material, and this secondary process is related to material removal really. So it is all about machining processes, and here the idea is that whenever there is a primary shape being incorporated either by a casting, or as we will see later through forming processes, the engineering parts that are so made have to go into assemblies or structures where more than one parts are put together for having some sequences which would do, for example, motion transfer or power transfer, okay, and that is how machinery is realized. Okay. So therefore for such material removal processes are very important, because there is an issue of fitment with respect to each other, and there has to be certain process tolerance or certain fit and tolerance that are needed between the different parts which come out, so that they can be put together as an assembly. So therefore the material removal processes become very important. They are secondary manufacturing processes where additional unwanted material is removed, and they are removed in the form of chips from blank material, and typically by using a harder surface which is also called the tool, and the harder surface actually eats into the softer material, and that is how the chips are being process so that the final desired shape can be obtained in that manner. So, material removal is the most expensive manufacturing process because more energy is consumed and a lot of waste material is generated in the process of the manufacturing of the material using this secondary process. So, there is an impetus of course nowadays that can we really do without the need for this secondary material removal wasteful expensive process, and that is why people are going into additive manufacturing and components made as is in a finished state, which is actually one advancement over whatever this conventional way is of casting followed by machining, so that material goes into the assembly. So, there are many processes that we will discuss. Would be turning process, which is typically done in a lathe machine where the workpiece is rotated and the tool moves in a linear manner with respect to the workpiece, either radially or parallel to the axis of the rotating workpiece. We will talk about shaping, where there is going to be a let us say this operation here is illustrating form cutting. There is a tool which is in a shape or a form, and it produces the counter shape by scribing on the material surface, and so there is a downward feed that the tool has while the surface is moving back and forth against this in a perpendicular direction to that particular feed. We will also talk about milling processes, where there are multiple point cutting tools which are being utilized so that there is material removal. We will talk about drilling processes, grinding and sawing, and apart from that probably we will try to see some basic understanding into the chip formulation technique, how the material can be peeled off by taking the material to really the ultimate yield strength of the material, where there is a peeling off of in form of chips from the material. So, that is how the scribing process causing the material coming out as chips happens, okay. And so that is a very important process. So, this is the section that we will cover in such conventional material removal processes or machining processes. So, the other material removal processes which are available are also called the non-traditional, non-conventional processes, where there is not really direct metal to metal scribing action per se which is there, but it is a set of processes which either uses various forms of energy like mechanical, thermal, electrochemical, chemical energy to be actuated on the surface of a material which you want to get removed by virtue of that energy. And although there is some kind of a mechanical energy which may seemingly look like what happens in conventional machining, where there is the scribing and reaching of the material to the ultimate yield strength value of the material. But in this particular case, the energy mechanical is given by impingement, and this impingement is normally achieved by throwing a set of sand grains or a set of abrasive particles at a very high velocity to the surface, which can create brittle fracture. And these processes have been generated because there were a lot of requirements for a different range of material classes, including ceramics or metals, where the conventional machining process, particularly ceramics, etc., conventional machining processes won't work with that efficacy. So, in general, all such material removal processes, as you can see right about here, is classified into traditional and non-traditional processes. These classes would also be covered during this course, which talks about chemical machining, electrochemical machining, electrochemical grinding, electrodischarge machining, laser beam machining, abrasive jet machining, water jet machining, plasma beam machining, and ultrasonic machining, so on and so forth. And the traditional machining would have really cutting, where you have circular shapes through turning, boring, drilling, various shapes through milling, planing, shaping, broaching, sawing, filing, gear forming, gear generating, so on and so forth, and abrasion using bonded abrasives or loose abrasives, like in case of polishing and buffing you use loose abrasives, and this is very important particularly for the painting processes and the finishing processes of the applied paint to automotives and other engineering products. And then you have the grinding, honing, coated abrasives, which are more bonded abrasive processes. So, I am going to sort of, when we talk about material removal processes, go across all these different domains with an insight into how the chip removal process is taking place, what is the kind of limitation or parameter design for the process which is needed for this chip formation to happen or get actuated, and what is going to be the outcome once the chips get generated in terms of temperatures of the substrate, or for example, the surface finish or the average roughness of the surface. So, these aspects we are going to cover when we talk about these material removal processes. So, in a nutshell, what we are trying to do here is to cover with one primary and two such secondary processes. One is obviously the conventional and the non-conventional material removal process. In the part 2 of this lecture, we will probably try to cover the remaining manufacturing processes like the joining processes or forming processes with great details. So, I am going to close on this module in the interest of time, but in the next module I will start with a history of machining and how machining came into existence, and then what are the kind of tolerances which are achieved as machining grew or progressed, starting from the first machine tool which was power driven all the way to now some of the advanced CNC machining systems. So, with this I will close on this module. Thank you.